All right, guys, so we are still in Unit 3 talking about plants, and one of the most important parts of a plant is what it's grown in. So we're going to talk about soil for Lesson 4. Although there are plants in very rare occasions that can grow without soil, soil still is the number one medium used to grow plants. So it's important that we learn about what really makes up a good soil. So it says that soil is influenced by 5 elements. That would be minerals that form the basis of the soil, living organisms that affect formation, climate, topography, and time. So here we've got a picture that talks about the percentages. So organic matter about 5%, mineral 45%, air 20 to 30%. Nobody thinks about air being in the soil, but it is, and water 20 to 30%. And then it says the 5th one, which is time, is arguably the most important because it allows them to mix into the magic formula to make the best soil. So plants absorb water and nutrients through the soil through osmosis. Remember we talked about osmosis last lesson. They use their roots to dig through the soil and retrieve these elements. So 98% of the nutrients a plant absorbs is taken in through water, and the other 2% are from the soil. So the soil is very important. So soil needs to be porous. That means that there's air in there. So it doesn't need to be clay where it's all compact, so really sturdy and nothing can get through. So there's air in between the particles of sand, silt, and clay that make up the soil. Tightly packed soil, it doesn't leave any room for the roots to go spreading around. So it needs to be airy and there needs to be room. There's 16 nutrients that plants need to thrive, and all of them are on the periodic table. So you've got carbon, hydrogen, oxygen. They also need, these 3 are very important. NPK is how we remember it. Nitrogen, phosphorus, and potassium. Very, very important for plants. Calcium and magnesium and sulfur as well. These nutrients are acquired in large quantities by plants. So you can see those, find those on the periodic table. These elements are still important, but they don't need them as much. Boron, copper, chlorine, iron, manganese, I'm not going to say that one, and zinc. A bit like the salt or baking powder in a cake recipe, they are needed in small amounts, but they're still vital. So here it outlines the different elements needed for plant growth and says what they are for, the major ones and the minor ones. So this is really beneficial. Shows the importance of each one. I'm just going to highlight a few. So let's talk about this NPK that I said was so important, and we'll talk about why. So nitrogen, it's really important for stem and leaf growth, gives the dark green color, synthesizes amino acids and proteins. A good way to know if your plant is low on nitrogen is if it looks yellow in color, because nitrogen gives that dark green color. Phosphorus, that's for root development. We talked about how important roots are. Helps cell division, aids plants for a vigorous and rapid start. Potassium, plant vigor and disease resistance. Aids transports of food, thickens cell walls. All of that, great things. That's why nitrogen, phosphorus, and potassium, you will always see those listed in fertilizers and in like soil that's for sale. Next time you go buy some, make sure you take a note of that. So when there's a deficiency of an element, plants have specific symptoms. I talked about the nitrogen. It says if corn doesn't have enough phosphorus, the lower leaves develop purple undersides and make weak stalks, and they're not going to give good ears. So there's all great ways to tell what an element needs, and if you're a really good horticulturalist, you're able to tell those and find a fertilizer that will help that plant. So understanding a fertilizer label. This is where it talks about the NPK. So it's very important. These 3 are always going to be printed like this in a fertilizer label. N, nitrogen's first, phosphorus second, and then potassium is third. And that's going to list the rates of it. Okay, so and they'll have an analysis of the guaranteed amounts of all nutrients that are in there. Another element that's really important to soil is pH. Okay, pH levels. You don't want a really acidic soil. or a super sweet soil. Okay, so it says like a substance like lemon juice has a low pH, lower is more acidic, and something that's not as acidic, more alkaline, which is more basic, is going to have a higher number. Soil's too acidic, some elements of the plants aren't going to be able to be as prominent. You can adjust pH levels by adding lime, sulfur, or gypsum. You can actually take parts of your soil and go take them up to your local extension agent, and they will test it, and they will tell you what to add. So that's really cool. There's different classes of soil. Soil is very important. You can go to college and you can be a soil scientist. And it's important because you need to know the soil before you know what can go in it. If it can grow things, if you're wanting to be a farmer, you want to know if it's going to be stable, if you're going to build on it. All of these are great reasons to have soil scientists. So there are different classes, and it talks about each one. It goes all the way to class 8. And the USDA, when they rank your soil, they can rank it in any of these classes. So they go from it has few limitations that restricts their use. That's class 1. That's great. All the way to they have severe limitations, make them generally unsuitable for cultivation. That means you could not plant crops in it or even a garden. Or let's see, we've got soils have severe limitations, reduce the choice of plants, require special conservation practices, or both. So you could grow some things, but you're going to have to only grow specific things. Not everything's going to grow easily there. So that's pretty neat how it's classified. Soil is also classified into horizons. We call different soil levels horizons. And they're classified by letter. So you've got O, A, E, B, C, and R horizons. Okay, so the O horizon, that's O for organic matter. So that's animals, plants, insects, microbes, as well as some mineral matter. The A horizon, that's the next level. That's organic and mineral matter. And that's where the topsoil, that's topsoil. The E horizon, that's finer material, that's the clay. Okay, medium-sized particles are called silt and larger are sand. It's not present in all soils, but often found in older soils and forest. The B, which is the next one, is subsoil. So it's composed as the same elements as the topsoil, but as soil moves farther from the surface, it's less fertile. The C horizon, it doesn't really contain any nutrients, but it's important for holding water. And the R horizon, that's the bedrock. So that's where the soil ends because it becomes solid, as you can see. So soil is into 3 different textures as well. You have coarse, sandy, coarse textured or sandy soil. So it's large grains. It holds together when it's wet, but it crumbles when it's dry. Then you have medium, which is loamy. That's a lot of, North Texas is going to have loamy soil, west, mixture of sand, silt, and clay. When it's wet, it can be balled up and holds its shape. And the third is fine textured soil. So it has a lot of clay in it, forms hard lumps or clods when it's dry, like the kind of clay you may have used in art class. So this is not very good for growing because it's not very porous or airy. So there's a lot more to soil than you may think. There are whole careers that are just on developing soil and fertilizer, so that may be something that interests you. And this is the last lesson on the plant side. Our next one, we're going to go over our professional